Hi everyone, my name is Jason Wang, currently a senior here at Luddy, majoring in computer science and finance. I'm also a peer tech advisor at the Career Services Office, and this is going to be the first episode of the coding question of the week, where we'll be walking you guys through a different interview style coding question every single week to help you prepare for internship, full-time interviews, or maybe just being a better programmer overall. So this week we're covering a really famous problem. It's called two-sum, and one of the main reasons I really enjoy this problem is because it's a pretty simple concept to understand. It's nothing complex, but there's a lot that you can really do here to make the solution more efficient, right? So let's start off by reading the prompt. Given an array of integers, nums, and an integer target, return the indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. And by the way, we're using LeetCode. So for those of you that don't know, LeetCode is an excellent free resource for interview prep. It has a huge database of free interview practice problems, as well as discussions and solutions. So if you aren't using LeetCode for interview prep already, you definitely should be. It's great. So LeetCode is providing us some great examples here. So we have this array 2, 7, 11, 15, and our target is 9. So me immediately, I'm looking at 2 and 7. Okay, great. Those should add up to 9, and we want to return the indices, not the values, but the indices. So we should return 0 and 1 here. It's great. In this example with 3, 2, 4, 2 and 4 add up to 6, so we're returning 1 and 2, etc., etc. So that being said, I will be coding this today in Java. We will probably mostly be using Java, at least for me. And I'll also be using IntelliJ just because I'm a little used to the IDE environment. It just helps me focus a little bit better, something I'm more comfortable with, and then we're just going to be copy pasting the code over. So as you can see here, I have this prompt pasted over so we kind of know what we're working towards. And great, let's get started. So the first thing I'm going to do here is we're going to make the integer array. Oops. So we know that it's going to be an integer array of size 2 because it's going to have two numbers in it. It's going to be those two indices, and then we're going to return. We know we're going to return it at some point, right? And the code in between here is what we can have to fill out. So the first thing I'm thinking is the brute force solution, which is probably the most obvious solution, which is just to look at every single element in the array and then iteratively compare it to every other element, right? And we can do that with a nested for loop here. And I'll explain the parameters in a second, but really what we want to do is, like I said, we're checking each, sorry about that. We're checking each element in the array here against every other one. And for that reason, we can start I at 0 and only go to nums at length -1, or the second to last element. And then we'll start j at whatever element comes after I, and we'll go all the way to the end. That way we're not double checking anything, right? And when we compare two numbers in the array, and remember they have to be different because may not use the same element twice, it's clearly stated in this problem. Because they have to be different, we need to make sure that I and j will never be the same value. Okay. So, I mean, with this for loop, it's guaranteed to never be the same value because j will always start after I, and they have different parameters. Great. So if it's going to be a super simple if statement here. So we're just checking if the two elements that we're on is equal to the target. If so, that's great. We plug in the indices that we have, I and j, into our ants, and then we return it. It's great. It has exactly one solution. So you could theoretically put your return statement here, but because of Java syntax, they also want something outside of the for loop. So we can just put it here. It's totally fine. And this is what we have. So what we're going to do now is we're actually going to copy. Okay, so we've copy pasted the code here. And what we can do now is we can run this code, and then LeetCode is going to run it through some basic test cases just to see pretty much if it works. Great, accepted. Now we can submit it. And when we submit it, LeetCode is going to do really important things here. Number one, it's going to analyze our runtime. Number two, it's going to analyze memory usage. So for those of you that have learned about big O complexity, both space and time, you know how important they are. And even if you get the right answer, you might be able to get a better answer that is faster or takes less space. So in this case, our runtime is pretty bad. It's only faster than 22.7%. And memory usage is also not great. It's less than only 41% of Java submissions. But let's think about this theoretically, right? From a space perspective, it's actually O of 1. It's constant space. And the reason for that is no matter how large this num's input is, the only space that we're using, that we're creating, is a space for this variable right here, ans, which will always be an integer array of size 2, no matter what we do. Always be that same thing. So no matter how big the input is, it's going to be the same space, so it's constant space. So it's actually O of 1. So despite what this memory usage says, we're actually getting the best memory that we can, more or less. In terms of time, so whenever you have a nested for loop like this, you should immediately know that it's n squared time, which is pretty bad, right? And the reason for that is as nums grows, the time it takes for our solution right now to run will grow exponentially, because you're comparing each element to every other element, right? So you're essentially doing the number of elements squared operations. So if you have size 10 array, it's going to take 100 operations. If you have size 100, it's going to take 10,000 operations, et cetera, et cetera, et cetera. So it grows really quickly. So our space is good, but let's try and cut down on the time. So remember what I said earlier, that this problem is really great because, again, the prompt is pretty simple, but it gives us an opportunity to really demonstrate our knowledge of the space here and demonstrate our ability to solve problems uniquely and creatively. So we know that the bottleneck was in the for loop. We're still going to have the same basic outline here. Oh, forgot my brackets. Right, the difference is we don't want to use a nested for loop because that would take a long time. So now I'm going to walk you through an O of n time solution, which uses something called a hash map. So for those of you that don't know, a hash map stores key value pairs. It's also known as a dictionary. So pretty much what a hash map does is, think of it like keeping a key, right? And then it has a corresponding value. So think of it like almost like a record book, where for each, let's say for each student, there's a corresponding ID number. Or the reason called a dictionary is because for each word, there's a corresponding definition. And you might be wondering, how do we use a hash map in this situation, right? Okay, well, that's pretty simple. So first what we're going to do is we're going to populate the hash map using a basic for loop here. Okay, so what are we putting in this hash map? Well, we're going through the integer or the given array, right, nums, and then for each element in that, we're putting it, all we're doing is putting those elements into a hash map, putting the element, and then its value or the corresponding value will be the index, right? Because we need to know, it's important to know the value here, but it's equally important to know the index because that's what we're going to be returning in our final array. So now that we have our populated hash map, what we're going to do is we're going to go back through the given array, right? And then we're going to have this temporary integer variable called complement, or just comp, because I'm a little bit lazy here. And it's just going to be the difference between the target and whatever current element we're looking at in the nums array. And now that we have that, it's pretty easy to say, oh, hey, if the hash map contains the key comp and the indexes aren't the same, and like this statement right here, diffs.getComp, because when you use the .get on the key in a hash map, it returns the value that corresponds to that key. And in our case, our key is the value, our key is the number, and then the value is the index. So we're saying if the hash map has the complement that would add up with our current element to the target, and the index of that complement is not the same, so they're two different elements, then great. we found our answer. We can again go, plugging in our two indices here, and then we're pretty much done. We know this is going to be exactly one solution, so we simply run through our entire code, and there will be, at some point in this for loop, an answer that fulfills our statement. We'll populate our answer array, and then we return it. So we can go ahead and copy paste. Okay, so now we got 68 ms and 40 megabytes. Let's run this code first before we submit it. Let's see how much we can improve here. So we submit it. Okay, so we went from 68 ms to 2 ms, which is very good, right? So now we're faster than almost 80% of submissions, and our memory is incredible. It's less than 97%, which is actually interesting. And one thing I will say about LeetCode is when you submit the runtime and the memory usage, you should kind of use them as like gauges. They're not super accurate, and you should definitely look at the big O complexity. Like you should put more weight on that. And the reason is because if you look at this, the space is actually going to be ON, not O1. So our last solution was O1, which is better than O of N, but this is going to be O of N because we're creating a whole new hash map that is going to be, in the worst case, as big as the given array. So assuming they gave us an array of 1,000 values and each value is distinct, our hash map is going to be of size 1,000. So in the worst case, it's going to grow with our nums array. So it's actually ON space. So this should be worse, but the way that LeetCode runs their tests when you submit them, they have some variability, but understand that this is actually takes up more space. But the time is the biggest improvement here, right? And the reason for that is we have taken an original ON squared solution and made it O of N, because the only thing we're doing now is going through the array exactly twice, right? The number of times you go through the input array doesn't change with the size of the input. It will always be twice. So now it's going to be linear time, which is great because exponential time is really, really bad. So this is what's called the two-pass hash table approach, because first you go through the array to populate the hash table, and you go through the array again to actually search through the hash table. And this is great, right? We got huge improvements, but there's actually one more thing that you can do to make this solution a little more elegant. And what we're going to be doing is combining these two passes into the same step. So we're pretty much going to keep a lot of the code the same, right? The only difference is we still have our comp. And we still are going to have this similar if check here, right? If the hash map has the key, then great, we have our answer. Otherwise, if the key is not in there, right? If we don't know, if we don't have the current complement, then we just stick whatever element we're on. Into the hash map. So this kind of solution is both checking the hash map and populating it at the same time. So this is what's known as the one pass hash map solution. So you run this code. Well, again, this is still O of N space and time. So we don't actually have any like asymptotic improvements here. But just for fun, we'll see what we do. So yeah, roughly the same metrics as before. And you can kind of compare all your submissions here. I have a lot of submissions from this problem a lot of times, just trying out different things. But as you can see, we've gone ON space, ON time, which I think is the fastest and most optimal solution for this problem. But if you guys have any other unique solutions, or maybe you can beat it, maybe you get an O log N or somehow an O1 solution. I don't know how you do that, but if you have other more creative solutions, feel free to submit them, send them in. And if you have any other questions, feel free to reach out to me at wang18@iu.edu. Having said, this has been the first episode of Question of the Week. Hope you guys enjoyed it. Hope you guys learned something, and I will see you guys soon.